In the last class we had seen how to multiply two matrices. So today we are going to see the properties of matrix multiplication. Properties of matrix multiplication. So matrix multiplication is possible if number of columns of one matrix is equal to the number of rows of another matrix. A is a matrix of order 2 by 3 and B is a matrix of order 3 by 4. Then you can see here number of columns is same as number of rows. Hence this matrix multiplication is possible. The product matrix is supposed denoted by P. The order of the product matrix is 2 by 4. If we multiply matrix B by matrix A, the number of columns and number of rows of the matrices do not match. Hence this product of matrices is not possible. Let us take square matrices of order 2, a matrix A defined this way and another matrix B defined as this. The product matrix AB is possible, which is of the same order, and the product matrix can be obtained as multiplying first row with the first column elements. So we get here 5, 3 plus 8, 11. Here you get 0, minus 2, 0, minus 4. This is the product matrix AB. The product matrix BA is also a square matrix of the same order. Here again if we multiply 1 plus 0, 2 minus 3, here is 2 plus 0, 4 minus 4. So from here you can see that the product matrix AB is not equal to the product of matrices B and A, and hence we can say that matrix multiplication is not commutative. I am considering here as an example square matrices of order 2 only. Let us multiply a matrix with an identity matrix. So square matrix of order 2 multiplied by identity matrix of order 2 gives us on multiplication the same matrix, which is A. If we multiply identity matrix with matrix A, we obtain the matrix A only, and hence we can conclude that product of A and I is equal to matrix A, which is also equal to I into A. Although we have said that matrix multiplication is not commutative, but it is commutative only if the matrix is multiplied by an identity matrix of the same order. Obviously matrix A has to be a square matrix. In a similar manner, a matrix A multiplied by a 0 matrix will give the result 0 matrix, which is same as 0 matrix multiplied by a square matrix A. If lambda is a scalar and it is multiplied by a matrix product matrix AB, obviously this multiplication is possible. Then this is same as the scalar into matrix A multiplied by matrix B, which is same as matrix A multiplied by lambda times matrix B. So here this is scalar multiplication, this is also scalar multiplication. The distributive property of matrices. If A is a matrix multiplied by the sum of matrices B plus C. Now when I am saying this, the order conditions are thought to be satisfying. This is equal to AB plus AC. Likewise, matrix A plus B multiplied by matrix C is matrix AC plus matrix BC. The first multiplication, where we are multiplying by matrix A from the left side, is known as pre-multiplication by matrix A, and here in this case we are multiplying by C after adding, so this is known as post multiplication by matrix C. The associative property of multiplication of matrices holds true. Matrix AB multiplied by matrix C is same as matrix A multiplied by the product of B and C. Now let us also see some very special cases of matrix multiplication. I am taking specified examples here. This is matrix A and matrix B. The product of matrix A and B will be a square matrix of same order. So going multiplying rows with the corresponding columns. First row multiplied by second column, second row multiplied by second column, we get a 0 matrix. Matrix B into A. So here again first row multiplied by this gives 0, second row multiplied by this 1, this into this is 0 and again 0. This is not a 0 matrix. So once again from this example we get to know that matrix AB and BA are not equal to each other, so matrix multiplication is not commutative. For this particular example only, we can be asked a question, give an example of matrices A and B so that matrix AB is a 0 matrix, but neither matrix A is 0 matrix nor matrix B is a 0 matrix. So here you can see the product of A and B is a 0 matrix, but matrix A or matrix B are not 0 matrices. Give an example of matrices A and B such that AB is a 0 matrix, but BA is not a 0 matrix. So with the same example, you can see here the product of AB is 0 matrix, the product of BA is not a 0 matrix. Give an example to show that matrix AB is not equal to matrix BA. For this you can give any example. This example suits all the three cases. Now one more special case we will discuss. Give an example of matrices A, B and C such that matrix AB is equal to matrix AC and matrix B is not equal to matrix C and matrix A is not a 0 matrix. So let us find out here product of AB. Suppose matrix A is defined as a square matrix with all elements 2 and matrix B is defined as a square matrix with these elements. So if we find out the product is 2 minus 2, 0, here is 2 minus 2, 0. This is a 0 matrix. The product of A and C, matrix A is the same, and let C matrix be given by these elements. So here once again, when we find out the product matrix comes out to be a 0 matrix. So the first condition is satisfied, that AB and AC are equal. Both of them are equal to 0 matrices. This condition is also specified, or is very clear. B matrix is not equal to C matrix. Here we have defined B matrix this way and matrix C this way. So B and C matrices are also not equal, and matrix A is not 0. Matrix A we have defined as a square matrix with each element equal to 2, which is not a 0 matrix. So these are some special cases. The cases which we have just discussed can be asked in the board exam as 1-mark questions.